Good evening friends, this is Professor Vishal and in today's session we are going to continue our first chapter, that is some basic concepts of chemistry. So up to this what we have seen, we first see the classification of we saw the classification of chemistry, then we completed various laws of chemical combinations, then we have studied Dalton's atomic theory, then we also discussed about the modern atomic theory, then after that we discussed the Avogadro hypothesis, isn't it? And in last session I think we discussed about the Avogadro hypothesis, what exactly the definition of atom and molecule given by Avogadro. Classification of molecules we have also discussed, that is two types of molecules are there, homoatomic and heteroatomic, isn't it? Then we have studied atomic mass, concept of atomic mass. Now we started I think molecular mass, concept of molecular mass. We are going to discuss about this concept, that is molecular mass, in today's session. And after that, after molecular mass, we are going to see the various examples through which we can try to understand what exactly the molecular mass. Then we are going to discuss about the relative or average atomic mass of the various compounds. Then we will see percentage combination of all these things. Okay, so let's start with molecular mass. Now basically actually it is the total mass contained in a molecule. We can say it as a actual mass contained in a molecule of the molecules. Okay, for example, and let us say first example and give you example 1, that is H2O. Okay, as we all know, hydrogen atom having atomic number as 1. So here we will see 2 atoms are there, so I will multiply it by 2. Okay, so I am going to add this oxygen, only 1 atom is there, so atomic number is 16. So it becomes 2 plus 16, so I can say 18 unit is the molecular mass of H2O. Okay, so we can see one or two examples of this. Let us say H2SO4. Okay, second example, H2SO4. Okay, here if you see again 2 atoms of hydrogen, atomic mass is 1. I am just underlining atomic mass here. Okay, plus sulfur, atomic mass is 32. One and only atom is there, so I just write here 32 plus O4. Here if we see atomic mass of oxygen is 16 and there are 4 atoms. Okay, if I will solve it, I will get 2 plus 32 plus 16 for the 64. Then after that 32 plus 64 is a 8, and 6 plus 3 9, 98 unit. So 98 unit is the atomic molecular mass of the H2SO4. Then we will see one more example. So if atoms are combined in a complex ratio, we will see one more example. Let us say C12 H22O7. We commonly call it as a sucrose or table sugar, isn't it? So here if we see carbon atoms, there are total 12 carbon atoms whose atomic mass is also 12. So this is atomic mass and this is atomic mass in previous example. Okay, so here if we see hydrogen 22, so 1 is the atomic mass, 22 total masses, total atoms. Here O7 means 16 into 7. Here 16 is, here 1 is atomic mass. Okay, so if we calculate it, 12 are 144, 22 plus 16 7s are 6. I think 6 7s are 42, 4 is remaining, 7 6 are 42, 4 is remaining, 7 1s are 7 plus 4, 11. It is 122. Okay, if I will add it, I will get 2 plus 2 plus 4, 4 plus 4 8, then 1 plus 2 3, 3 plus 4 7, and here 1 and here 1, so 278 I think so. 144. Actually it is C12 H22O11. Okay, I have to calculate with this. I'm writing here formula for sucrose somewhat wrong. Oxygen total 11 molecules are there, so I will correct it. So it becomes 16 into 11. So if I will calculate it, 16 1 11 6 is 66, 6 is remaining here, 11 1 is 11 plus 6 17. So now I will correct it. I will get is 7 plus 2 8, 8 plus 4 12, 1 is remaining 7, sorry 6 plus 2 8, 8 plus 4 12, yes, 1 is remaining 7 8 8 10 14, 1 is remaining again 1 plus 1 plus 1 2, 2 plus 1 3, 342. So this is what the molecular mass of sucrose, isn't it? Yes, it is 342, correct answer. Then we will see one more example, one or two examples. Let us say urea NH2CO NH2. Let me just rub it. Or let us say fourth number NH2O NH2, that is urea. So it is CO, okay, CO NH2CO NH2. So if we calculate it for sodium, it is 40, sorry, nitrogen it is 14, as it is, plus 2 atoms of hydrogen, only one atom of nitrogen is there, so I am just writing there 42, sorry 12, that is 14, sorry, for nitrogen it is 14, plus H2 means 1 is the atomic number into 2, plus for carbon it is 12, plus oxygen it is 16, only one single atoms are there, plus again nitrogen plus 2 atoms of hydrogen. Okay, so if I will add it, 14 plus 2 plus 12 plus 16 plus again 14 plus 2, so it is I can say 16 and 16, 16 3s are 48, 48 plus 12, so it is I think 50 units. Okay, 50 unit is the molecular mass, sorry, 48 plus 12, 60, not 50, isn't it? So 60 unit is the molecular mass of urea. This is sucrose, this is sucrose and this is urea. Now after this we will see last example, that is acetic acid CH3COOH. Okay, so CH3COOH is common name is vinegar, isn't it? So here again carbon 12 plus 3 atoms of hydrogen plus again 1 atom of carbon, again 2 atoms of oxygen, again 1 atom of hydrogen. Okay, so if I will simplify it, I will get 12 plus 3 plus 12 plus 16 plus 16. Okay, so if we add it, 15 27 plus 1 28 and 32, it becomes 60 units. Okay, so in this way you can easily calculate the molecular mass. Okay, basically it is the sum of total of mass of all the atoms. How we can define molecular mass? Sum of, I am adding, isn't it? So it is sum of total of all the atoms of the molecules. So here I am considering nitrogen, hydrogen, carbon, oxygen, like all the molecules, all the atoms of the molecules. Okay, sum total of all the atoms present in a molecule, we commonly define as sum total of all the atoms present in a molecule is nothing but the molecular mass, and this is how we can easily calculate. So I have given you total 5 examples, and with the help of which you can easily understood this concept. Okay, then after this we are going to discuss about the next term which is correlated with this, that is gram molecular mass. Okay, basically gram molecular mass is, it is nothing but molecular mass, but when we mention this in unit gram, so now here I am writing unit, isn't it? I don't know the exact unit, so instead of unit, if I will mention this molecular mass in gram, so it becomes gram molecular mass. Okay, so I will give you this first example again, when we are discussing about the gram molecular mass. Okay, means if molecular mass expressed in grams, if molecular mass expressed in grams, we call it as gram molecular mass, okay, or we can shortly write it as gram molecular mass, GMM, okay. So for example, in case of H2O, we have seen here again two atoms, 1 into 2, just I directly write 16, so 18 unit. If 18 unit is the molecular mass of hydrogen, its gram molecular mass equal to 18 grams. So this is how simple it is, okay. So you can take any example. Let us say if you take NH2CONH2, that is urea. So in that case also you will come to know it is found to be, I think, 60 unit. So 60 unit, instead of 16 unit, I can write the gram molecular mass as a 60 gram. So this is nothing but molecular mass, gram molecular mass. If we express this molecular mass in terms of gram, so that itself is gram molecular mass. Again, one more concept is there after this gram molecular mass. I hope you will understand it. It is very simple. The next concept is formula mass. Basically, formula mass is nothing but it is similar to molecular mass, but when molecular mass of ionic compounds is calculated, it is called formula mass. Okay, it is also written as FM. So when some formula mass is nothing but molecular mass, or we can say it is similar to molecular mass, but or we can say it is the special kind of mass for ionic compounds. Okay. For example, what is the ionic compound? Then let us say NaCl. Okay. For example, I am discussing about NaCl. Then if we see, as we all know, sodium is atomic mass 23 and its correct mass is 35.5 for chlorine. Okay, if I will add it, it is nothing but 35 plus 8 and it is 5, 58.5, isn't it? So 58.5 is what? It is nothing but the formula mass of NaCl. Okay, isn't it? The same procedure is there as we calculated the molecular mass. We have to calculate molecular mass only, but when we calculate molecular mass of ionic compounds, so this word is here important. For ionic compounds, it is called molecular mass is calculated of formula mass. Okay, or we can say formula mass is a special case of molecular mass, isn't it? Even the same thing. So in this way, you can take any ionic compound and calculate the molecular mass. Only here we have to calculate the molecular mass, and that molecular mass itself of ionic compounds is known as formula mass. Okay, so these three terms are important: molecular mass, gram molecular mass, and formula mass. So after this, we are going to discuss about the most important concept in this chapter, that is known as mole concept. Okay, now when we discuss about the mole concept, we must know what exactly the units. For example, I will give you, let us say, when we oftenly call it as a 1 dozen of banana. So 1 dozen by default includes 12 entities, isn't it? Or let us say 1 score. 1 score means what? It is 20 entities in it. Or likewise, one example, gross. 1 gross means what? 144 entities or articles we commonly call. Similarly, similarly this mole concept is there. Okay, means 1 mole of atom is nothing but the it is to be precisely, it is 6.02 into 10 raised to 23 grams. So 1 mole is nothing but, sorry, not grams, 1 mole is nothing but 6.02 into 10 raised to 23 atoms, whatever it may be. Okay, it may be atoms, it may be molecules, or it may be ions. That is most important. Okay, we will discuss about this. mole concept. Okay, basically as we already discussed, 1 dozen equal to 12 entities. Okay, similarly 1 score, equal to 20 entities, or 1 gross equal to 144 entities. Similarly 1 mole equal to 6.02 into 10 raised to 23 entities. Now here what do you mean by entities then in case of mole? So entities may be atoms, molecules or ions. Okay, so this is how we are going to study the mole concept. Okay, so I am giving you just examples. So these are nothing but the examples 1, 2 and 3. So with the help of these 3 examples I am trying to explain the mole concept. Or 1 mole equal to 6.02 into 10 raised to 23 entities. Now here entities in case of mole means what? Entities may be atoms, maybe molecules or maybe ions. Okay, whatever the whatever the particular compound or element or atom, it is available in that particular form. For example, let us say sodium. So sodium generally exists in the form of atoms. H2 is available in the form of molecules, isn't it? So in this way you can define the entities according to a respective example. Okay, so we will discuss this with the help of some examples. So this is how we studied the mole concept. Now in short, what we have to remember? We have to remember the only thing, mole. Mole is what? 6.02 into 10 raised to 23 atoms, molecules or ions. Okay, so let us say for example 1 mole of sodium means what? 1 mole of sodium means 6.02 into 10 raised to 23 atoms of sodium. Why it is atom? Because sodium exists in the form of atoms only, isn't it? Why I am writing here atom? Already I discussed entity may be atom, maybe molecule or maybe ion. But in case of sodium, why I am writing here atom? Because atom is nothing but sodium is available in the form of atoms only. Okay, so in this way I will give you one more example. 1 mole of H2, let us say 1 mole of hydrogen, so it is equal to 6.02 into 10 raised to 23 molecules of hydrogen. Now here why I am writing molecule? Because sodium exists in the form of molecules. Now if what should I do if I want to calculate the atoms? Okay, so let us see how we can calculate the atoms. Now for example, if I will give you as I already discussed, 1 mole of H2 is equal to 6.02 into 10 raised to 23 molecules. Why molecules? Because sodium exists in the form of molecules. If I want to calculate the atoms, isn't it? Therefore I can write, as we all know, this consists of 2 atoms, so number of atoms equal to 2 into 6.02, sorry, 2 into 6.02 into 10 raised to 23 means what? 12, approximately 12.04 we can say, into 10 raised to 23 atoms, or we can say 1 mole of H2 equal to 12.04 into 23 atoms. So in this way you can calculate the number of atoms Means what? Why I am multiplying this with 2 means what? I am just multiplying with by atomicity. Means what? Atomicity of hydrogen is 2. What is atomicity then? As we already discussed in previous lecture, I think atomicity is nothing but the number of atoms present in a molecule, isn't it? See, if I want to calculate the number of atoms in a given mole, for example, in this example, 1 mole of hydrogen contains 6.02 into 10 raised to 23 molecules. Okay. Now, if I want to calculate how much of atoms, it means how much of atoms instead of molecule, I am interested to know how much of number of atoms present in a hydrogen. Okay. Simply what I have to do, I have to multiply it by atomicity. Atomicity is nothing but number of atoms present in a molecule. So here atomicity of hydrogen is 2, that is why I am multiplying it by 2. So 2 into 6.02 into 10 raised to 23. So that multiplication gives me number of atoms present in a hydrogen molecule. Okay. So you can easily calculate this. For example, I will give you one more example. 1 mole of CO2. 1 mole of carbon dioxide. As we all know, 1 mole is nothing but 6.02 into 10 raised to 23. Isn't it? So it is available in the form of molecules. If I want to calculate atom, I have to multiply it by atomicity. So now atomicity of CO2 is what? It consists of 1 atom of carbon, 2 atoms of oxygen. So atomicity is 3. So if I want to calculate number of atoms in CO2, simply I have to multiply it by 6.02 into 10 raised to 23 atoms. So this multiplication gives me the answer. Okay. So in this way you can easily calculate. So here we calculated number of atoms present in a CO2. Just I have to multiply it by atomicity, because atomicity of CO2 is 3. So 3 into 6.02 into 10 raised to 23 gives me number of atoms present in a 1 mole of CO2. Okay. So I can easily calculate it. 3 to the 6, 0, and it is 18. So 18.06 into 23 atoms are available in 1 mole of CO2. Okay. So we will take one more example. 1 mole of oleum. Okay, common example is there. One mole of oleum. Oleum is nothing but H2S2O7. Okay, so it is nothing but 6.02 into 10 raised to 23, isn't it? So number of molecules. So if I want to calculate here, it is nothing but molecules, because it is available in the form of molecules. If I want to calculate atoms, as we already discussed, we have to multiply it by atomicity. So atomicity of H2S2O7, which is equal to 2 atoms, so 2 into 1, isn't it, plus S2 means what? 32 into 2 plus 6, sorry, plus it is 16 into 7. 16 into 7. So here we are calculating atomicity means what? Sorry, here I calculated the atomic mass. No, I am not interested to know the atomic mass. Okay, sorry, here we have to calculate the atomicity. So I just correct it and add atomicity of H2S2O7. So simply we have to count the atoms. So here 7, or here 2 plus 2 plus 7. So it becomes 4 plus 7, 11 atoms, isn't it? So atomicity of H2S2O7 is 11. Therefore, number of atoms equal to atomicity into 1 mole of particular element. Here in this case H2S2O7. So this is general formula. and discussing about. So atomicity is found to be 11 into 6.02 into 10 raised to 23. So this gives me number of atoms present in a oleum. Okay, so we can easily calculate it, multiply it by 11 simply. So which is equal to, so 10 raised to 23 as it is, 11 to the 12, so 1102, so 11 6 the 66. So this is what number of atoms present in a oleum. Okay, so in this way you can easily calculate the mole number of atoms if mole value is given. So this mole value is most important. Okay, so after this we are going to discuss about number of moles, concept of number of moles. So basically number of moles means what? Total number of moles present in a given compound. Okay, so now this, in order to calculate the number of moles, we are going to use three methods. Okay, so first method here is calculating number of moles when weight of the substance is given. Okay, when weight of the particular substance is given, and if I want to calculate the number of moles, so I have to use that case only. Okay, in second case we have to use number of particles. If number of particles are given, I have to use that second case. Okay, and in third case, if volume of that substance is given, if volume is given, I will use third case. Okay, so we will going to discuss about these three cases. Now this is very easy, you just have to go through it once, so it will be easier for you all. So I am discussing about number of moles. So here if you see number of moles, we can calculate by three methods, or I will shortly write here, there are three methods to calculate number of moles. Okay, we are going to discuss about these three methods. I have just listed out first and we will discuss one by one. When weight is given, when what we can say, particles or number of particles are given, weight is known, number of particles are known, and third one is volume known. So we can calculate number of moles in these three categories. Okay, now we will discuss one by one. First, number of to calculate the number of moles when weight is given. Okay, so here we have to use simple formula. Firstly, we will discuss about first method, that is weight is known. So number of moles, m equal to, it is denoted by small m, number of moles equal to weight of a substance divided by molecular mass. Okay, so what is molecular mass? Molecular mass, we latest we have studied it, number of or sum total, it is the sum total of number of atoms present in a molecule, that is nothing but molecular mass. So we have to use here, so I just write here, mathematically it can be written as W by M. Okay, now here we have to remember this M is what, or you can denote it by capital M also. This M is number of moles. Okay, and this small m, or I will write it as a molecular mass. Actually this is not as such notation, I just write in short form, weight upon number of molecular mass. So molecular mass, it stands for molecular mass. Okay, for example, let us say question is like this: calculate the number of moles of 20 gram of oxygen, sorry 64 gram of oxygen. I am writing here question. Question is like this: calculate number of moles in 64 gram of oxygen. Okay, O2. So as we all know, this number of moles equal to W divided by molecular mass. So W is given, it is 64 gram, only we have to calculate molecular mass. So So this molecular mass can be calculated. We just write it down. Weight is 64 gram. Molecular mass for oxygen is molecular mass. It is nothing but the total number of atoms present in a molecule. So it contains 2 atoms. So 2 into 16 atomic weight. So it becomes 64 divided by 32. So it is 2. So we can calculate. We can say that there are total number of moles or 2 number of moles present in a 64 gram of oxygen. Okay. So here answer is 2 moles. So in this way you can easily calculate the number of moles. So this is the first case. Okay, I am discussing about weight is known. So weight is 64 gram. You just have to divide it by molecular mass. So molecular mass is for oxygen it is 16. For oxygen it is 32 actually, because 2 atoms are there and atomic mass of oxygen is 16. So 16 to the 32. So I will divide it. I will get 2 moles. So I can say that in 64 gram of oxygen 2 moles are there. Okay, so number of moles are 2 in that case. So we will see second method that is number of particles are given. Okay. Second method, number of particles are given. Okay. So again we have to use the same formula, molecular mass m equal to number of particles divided by molecular mass, isn't it? Only we have to replace this name of that method. Means weight is given, we have to take weight of that particular substance. Number of particles are given, we have to use number of particles, because denominator is same, molecular mass. Means what, in all 3 methods you have to calculate molecular mass. So that is why I give some more time or give 4 to 5 examples to calculate the molecular mass. This is most important. Okay. Now in this case you will see one more example. Calculate the number of moles in, we will write here question again. Calculate number of moles in, it is given that 3.0 into 10 raised to 23 molecules of CO2. 3.01 into 10 raised to 23 molecules of CO2. Okay. Here if you see formula m equal to number of particles. I am just writing here number of particles means here it may be molecules, it may be atoms, it may be ions. Again I will discuss, or here you can use number of entities are given, no issue. So here it is given that 3.01 into 10 raised to 23. Okay. Only we have to calculate the molecular mass of CO2. See here in case of CO2, if you see molecular mass of CO2, you can calculate. Okay, it will give your answer in an easy way.